So the next topic is equation of circle under various conditions. So standard forms you already discussed, but these are like special cases which you come across in problems. So we say equation of circle under various conditions. So the first thing that you are going to discuss here is we are going to write down the equation of a circle touching x-axis at a distance of alpha units from origin. It is touching the x-axis distance of alpha units from origin and cutting an intercept of length 12. You can take L also. So I'm taking 12 on y-axis. So this is the heading. I want all of you to find out what is the equation of such circle. You will not have only one circle, you can have more circles. Like I think you'll have around 4 circles possible in different quadrants. So can you tell me how to find those circles? Draw the diagram, you have to make out from the diagram. So based on this only, in JEE Advanced, I gave one question earlier. In the previous years, not in the recent years, but long back again. So the circle touches x-axis at a distance of alpha from origin. So it can touch right side or left side. So one possibility is it can touch right side and cut some intercept on the y-axis. So this is a possible circle. So it is cutting at a distance of alpha units like this. So this is alpha 0 and cutting some length on y-axis. That length cutoff is suppose AB, that is given as some 12. This is the first case. But I didn't say that it's touching positive x-axis. So it can touch even negative x-axis also. And I didn't mention that the intercept cutoff on y-axis is above the origin. It can cut it below origin also. So if I take below origin, I'll get one more circle. I'll just draw a little bit bigger diagram. So this is another possibility. So it can either cut above or below. And this length is 12. This length is 12. And this distance is alpha. So this point is alpha comma 0. So this is one situation where it is touching right side. Left side also it can touch. You can have more circles. So what are the other possibilities? If I draw the circle here, it can cut right side also. So it can be like this, touching here alpha units this side. So minus alpha 0 is this point. And the same thing you can have it down also. You can also have it down. So you can have 4 answers like this. So you can draw a better diagram. It's just a rough sketch. Okay. So I'll just erase one more time and draw it. I hope you understood, but still I'll draw it again. Yeah, like this, you can have 4 circles. So this is alpha 0. This is minus alpha 0. If I mark the center of the circles, so this is L and L. L and L, because that will be midpoint. A perpendicular drawn from center will bisect the chord. We'll have L and L there. So what will be the distance here? Alpha. So x coordinate is alpha. And this distance is the radius, so alpha comma r. This is the radius distance from x-axis y coordinate, so alpha r. And the one which is below will be alpha minus r. And the one which is this side will be minus alpha comma r. The one which is below will be minus alpha minus r. So that means you can have 4 possible circles. All are having the same radius, but different centers. And what is the relation between the radius alpha and this length L given? If you join this, for example, so this is the radius r, this is L, this is alpha. So by Pythagoras theorem, you can say r square is L square plus alpha square for all 4 cases. So r will be, you cannot have plus or minus because radius cannot be negative. This is the radius. same for all circles, but center keeps changing. So if I name the centers as C1, C2, C3, C4 in different quadrants, there can be 4 possible circles with these centers and the same radius. So what are those circles? So what is the circle in the first quadrant? So in the first quadrant, the circle is x minus alpha whole square plus y minus r whole square equal to r square. In second quadrant, the circle is having center as minus alpha r. So this will be x plus alpha whole square plus y minus r whole square is equal to r square. The third quadrant, if you look at the circle, it is having center as this one. So it will be x plus alpha whole square plus y plus r whole square equal to r square. And finally, for the fourth quadrant, what is the possible circle? The center is alpha minus r. So you'll get x minus alpha whole square plus y minus r whole square equal to r square, where r is nothing but in all the cases, what is the value of r? Under root alpha square plus L square. So is this clear? If they specially mention the quadrant, you can write that particular circle. If they don't mention, you can have 4 answers. So the second case would be, earlier it was touching x-axis and cutting some length on y. Now it is the other way. Equation of circle touching y-axis at a distance of alpha units from origin and cutting an intercept of length 12 on y-axis, on x-axis. So it's similar only. You can just try it once. So here also you can have 4 possible circles because I didn't particularly mention it is on the positive axis. So the possibilities would be so the circle has to touch y-axis, cut some length on x-axis. One possibility. Second possibility, you can have the circle touching down also. Or the circle can touch here and cut intercept like this. Or the circle can touch here and cut intercept here. So there will be 4 possible diagrams like this. And if I have to mark the centers of the circles, so I mentioned that it's cutting at a distance, touching at a distance of alpha. So this is given as alpha. And this is the radius. So distance from y-axis is x coordinate, distance from x-axis y coordinate. So this is r alpha this time. And this will be minus r alpha. This will be minus r minus alpha. And this will be r comma minus alpha. Again, if it is cutting some length L here and L here, if you join this. So this is alpha because this length is same as this length. Again, this is radius r. So r square is alpha square plus L square here also. R will be root of this. And if you have to write the circles in different quadrants, you can write with these centers. So the circle in the first quadrant has center r alpha. So it is x minus r whole square plus y minus alpha whole square equal to r square. For second quadrant, the circle has center as minus r alpha. So this will become x plus r whole square plus y minus alpha whole square equal to r square. Third, it will be x minus r whole square plus y minus alpha whole square equal to r square. And fourth quadrant, center is r minus alpha. So you'll have x minus r whole square plus y plus alpha whole square equal to r square, where in all the cases, what is r? Under root of alpha square plus L square. So something similar, but that alpha r position got interchanged here. Then the third case, equation of a circle of radius r touching the coordinate axis. touching the coordinate axis. So here also we can have 4 possible circles because I didn't mention that it's touching positive x and y. It can touch negative x and y also. So you can draw 4 possible circles. So a circle can touch here. It can touch in second quadrant. It can touch in the third quadrant or in fourth quadrant. So in all the cases, you are taking the radius as r only. Same size of the circle. So r here. So therefore, the coordinates of the center here will be r comma r. Here the coordinates of center will be minus r comma r. Here they are minus r. And here r comma minus r. So all the circles you can write down with the centers and radius is same only for all of them. So the circle in the first quadrant would be x minus r whole square plus y minus r whole square equal to r square. In second quadrant, the circle is having this as center. So x plus r whole square plus y minus r whole square equal to r square. And for third quadrant, you can write x minus r whole square will become x plus r actually. Y plus r whole square equal to r square. For fourth quadrant, the circle would become x minus r whole square plus y plus r whole square equal to r square. So these are the 4 circles. And if you want to club them, you can also represent them as x plus or minus r whole square plus y plus or minus r whole square equal to r square. If you want to write all the 4 together, that is either you will take both plus, both minus, plus minus or minus plus, it will give 4 cases. So this is all the 4 put together. So let's discuss the 4th case. Equation of circle passing through origin. Equation of circle passing through origin and cutting off intercepts of lengths A and B on x and y axis. A and B on the x and y axis respectively. Y axis respectively. So here the circle has to pass through origin like this, and it should also intercept some length on x and y. So this length is A and this length is B. I'll first show only for first quadrant. So what is the circle which passes through origin, cuts off length A and B on coordinate axis means this is 90 degrees. So this line is actually going to become a diameter. And A0 is this diameter, end of diameter. B0B is this end of diameter. If ends of diameter are given, how will you write the circle? X minus x1, which is A, into x minus x2, which is 0, plus y minus y1, that is y minus 0, into y minus y2 is y minus b equal to 0. This is how you write the circle. On expanding, it gives you x square plus y square minus ax minus by equal to 0. This is the circle. But this I showed it only for first quadrant. You can have this possibility even in the other quadrants also. Likewise, you can write for remaining quadrants. So I'll better show them separately. So if it is passing through origin, cutting intercepts like this, A and B. So in that case, this end of diameter is minus A0 and this end of the diameter is 0B. So in the previous equation, that A got changed as minus A. So here you can make it plus AX. You can straight away write this will be x square plus y square plus AX minus BY equal to 0. Same way you write for the other quadrants. So if it is for other quadrants, for example, if I show it for the third quadrant, this is A, this is B. So this is AB again. So minus A0 is for the coordinate of this, 0 minus B for this because they lie on the negative side. So the formula for this would become x square plus y square plus AX plus BY equal to 0 because when AB was there, you got this answer. A and B got changed as minus A, minus B. You are going to get this answer. This is for third quadrant. Finally, for fourth quadrant, so this is AB again. So this is A0 and this is 0 minus B. So the circle will be x square plus y square minus ax plus by equal to 0. This is for fourth quadrant. So if they particularly mention positive coordinate axis, first one is enough. If they don't mention, you can have 4 cases. So then we'll write down the next concept, that is intercepts made by a circle on the coordinate axis. So let's say, for example, a circle is cutting only x-axis. It can cut both also, but I'm taking the first case. The circle is cutting x-axis at A and B. Then we say that AB is the intercept cut off by the circle on x-axis. So if I want to find a formula for this, first I have to know the circle. So let the circle be x square plus y square plus 2gx plus 2fy plus c equal to 0. This is the given circle. And I want to find out the intercept which it cuts off on x-axis. So can anyone tell me how to find this AB length given the circle equation?
So solve with y equal to 0.
Yeah, because if the x-axis has the equation y equal to 0, if you put y equal to 0 here, basically you can solve this with the x-axis. So you'll get x square plus 2gx plus c equal to 0, which is a quadratic equation. And it will have two roots which are nothing but x coordinates of the point. Suppose this is x1 0 and this is x2 0. The point where they are cutting have y coordinate 0 and the x coordinates are suppose x1 and x2. They are the roots of this equation. So sum of the roots for a quadratic is minus b by a. So you'll get minus 2g. And product of the roots is c by a. So c. Once you know these two, if you want to find the distance AB, clearly you can say from the diagram it is x2 minus x1. You can also put a mod. And we can write this in terms of these two as root of x2 plus x1 whole square minus 4x1 x2. Like a minus b formula is root of a plus b whole square minus 4ab. I just use that. Then replace x1 plus x2 with minus 2g, x1, x2 with c. This will give you root of minus 2g whole square minus 4c. So root of 4g square minus 4c. Taking 4 common, it is 2 root of g square minus c. So this is the length of the intercept cut off by the circle on x-axis. Cut off by the circle on x-axis. And as a special case of this, if the circle is not cutting an intercept, instead it is touching like this, the intercept length will become 0. So circle touches x-axis, then what do you conclude? If circle touches x-axis, the length of the intercept is 0. So if you equate this with 0, you'll get a condition g square equal to c. That means for a circle to touch x-axis, g square should be equal to c. And for this to intersect, what are the criteria? There will be 3 cases. The 3 cases would be the circle will intersect x-axis like this, or the circle may touch x-axis like this, or the circle may not cut x-axis at all. So for this, g square will be same as c. For this g square, the value, because when you wrote the intercept length, this quantity inside the root cannot be negative. G square minus c is positive. So g square is greater than c. And if it is not cutting at all, the roots are imaginary. So g square is less than c. So these are the 3 criteria you can remember. This is for x-axis. Similarly, we can do for y also. Okay. So similarly, if you do it for y-axis, I'll straight away write it. Intercept made by a circle on y-axis. So you basically say length of intercept made by a circle on y-axis is 2 root of f square minus c. So I'm not deriving again. So earlier you put y as 0. This time we'll be putting x as 0 and doing it with the same method. And you can say if a circle intersects y-axis in two distinct points, f square will be greater than c. And if a circle touches y-axis, f square equal to c. And the third case, if the circle does not intersect y-axis, then we have f square less than c. So even though we wrote for x and y separately, sometimes the circle can cut both the axes also. Sometimes it may not cut both the axes. So the possibilities could be the circle may cut x-axis, not cut y-axis. It may cut y-axis but does not cut x-axis. One second. So the first possibility was it was cutting x, not cutting y. Now it is cutting y but not cutting x. Then next possibility could be the circle touches only x. It touches only y. Like this, you can have cases. Like what would you write for first case? If it's cutting x-axis, g square is greater than c. And not cutting y, f square less than c. And if it is not cutting x-axis, g square less than c. Cutting y-axis, f square greater than c. Both conditions you can write together. And here, cutting x-axis, so g square equals c. Not cutting y, so f square less than c. It is touching y, so f square equals c. Not cutting x, so g square less than c. Like this, you can write several cases. If it is touching both the axes, or if it is not cutting both the axes, then g square less than c, f square less than c. If it is touching both the axes, it can touch in other quadrants also. So that's why you'll get plus or minus. G equal to f equal to plus or minus root c. Because it can also touch in other quadrants. You can show that also. So there is a variable circle having a radius fixed and passing through origin, which is meeting coordinate axis in A and B. What is the locus of its centroid? So it is given that the circle passes through the origin and has a fixed radius. And it is cutting intercepts A and B, and it is a variable circle. Variable circle means this OA and OB are going to change. OA and OB are going to change. So since they have already given the radius as A, diameter will be 2A. So this is 90 degrees, angle and semicircle is right angle. This is 2A. C is the center, this is A and A. So they are asking us to find the locus of centroid of triangle OAB. But for that, we'll first assume this as some P and Q. Since A is already there, we'll not assume A and B. So this point will be P comma 0 and this point will be 0 comma Q. And since you want the locus of centroid, assume that the centroid has some coordinates and related with OAB. So suppose that G is the centroid XY. So how do you get the centroid when you know three vertices? You can just add them and divide by 3. This is 0, 0, P 0, 0, Q. You add them and divide by 3. You will get P by 3 comma Q by 3. So we get X as P by 3, Y as Q by 3. And since you want the locus of centroid, you need an equation XY. So P is 3X and Q is 3Y. You have to impose some condition on P and Q and remove it and get an equation XY. And what is the condition you can impose? Clearly, this P, Q and this 2A. AB is the diameter 2A. They form a right angle triangle. So we have P square plus Q square equal to AB square, which is 2A whole square. So let us use this result and then eliminate P and Q. So we can use P square plus Q square equal to 4A square. Writing this, P square would be 9X square. Q square would be 9Y square. So the locus is 9X square plus 9Y square equal to 4A square. This is the required locus. So now if you look at the options which is matching, the first option. So consider the four circles given by x plus or minus 1 whole square plus y plus or minus 1 whole square equal to 1. What is the equation of smaller circle touching all these four circles? So these circles are like this. So because the centers are 1, 1, taking both plus, then you have 1 minus 1, 1 plus and 1 minus, then minus 1 minus 1 and 1 minus 1. You can see that there are four circles contained in this equation, taking both plus, plus minus, minus plus and minus minus. So all the four are written. So these are the four circles which are touching the coordinate axis. You want a smaller circle touching all these four. So if you want a circle touching these four, one can be drawn here and the other can be drawn here. So since you want to find the smaller circle, you have to find the blue one, the circle drawn in blue color, you have to find that. So now you can try. So by symmetry, clearly you know origin is the center. Only radius, if you find, you'll know the answer.
Sir, is the answer option D?
I think it's correct. So if you join the centers, and let us suppose this point is P, the radius of smaller circle is R, and this circle is having radius 1. So clearly the distance between the centers, if this center is some C1, the distance between the centers OC1 is equal to sum of the radii, R plus 1. And the value of OC1 you can write by distance formula for 0, 0 and 1, 1. So root of 1 square plus 1 square equal to R plus 1. R is equal to root 2 minus 1. And center is origin by symmetry. So required circle will be x square plus y square equal to R square. That is root 2 minus 1 whole square. So which is nothing but 3 minus 2 root upon expanding. So D is the correct answer. So this is easy only. Only thing you have to draw the diagram properly. So what was the formula for length of intercept on x-axis I gave you? 2 root of g square minus c. You can use that. You can do from diagram also, or you can use that formula also. So there is a circle which makes an intercept of length 2a on x-axis. This is set 2a. I'll name it as AB. And it passes through 0, comma b. So where is 0, comma b? Actually on y-axis. So probably you can see that the circle also cuts y-axis in that case. So they didn't say it is touching at 0b. So passes through 0b they mentioned. So I'll not show the y-axis, but I'll just mention 0b somewhere here, not required to show it. Then what is the locus of its center? So if the center is somewhere here, you want the locus of the center. So suppose the center has some alpha beta as the coordinates. You have to find locus of center means you need an equation in alpha beta. So how do we do this now? So if you drop a perpendicular like this, what is the distance from center to x-axis? It should be the y coordinate. So this should be beta, I can say. Because the distance from x-axis y coordinate, so center to the x-axis, that is beta, you can say. And also you can say this is a and a because the total length is 2a and m is the midpoint. And if suppose if I take this as radius r, how are they related? R square is equal to beta square plus a square. By Pythagoras theorem, I related r, beta and a. And I can also write the value of radius by writing this, because the radius is also distance between these 2 points. So r is also equal to root of alpha square plus beta minus b whole square using distance formula. So this value of r you substitute here. So r square would be replaced with this value. So without the root, alpha square plus beta minus b whole square equal to beta square plus a square. Now just expand it. You can write alpha square plus beta square minus 2 beta into b plus b square. Expanding this with a minus b whole square equal to beta square plus a square. So that is equal to beta square plus a square. Both sides you can cancel beta square. And since you want the locus of the center alpha beta, you have to replace alpha beta with xy. So that would give you x square minus 2by plus b square is equal to a square. So if you look at the options, we have x square equal to, this option is x square equal to a square minus b square plus 2by. So which option will match? We'll see. X square equal to a square minus b square plus 2by. So option B will match. The radius of the largest circle that can be drawn to pass through 0, 1, 0, 6 and which also touches x-axis. Largest circle means radius should be maximum. So usually they are saying it should touch x-axis, pass through 2 points 0, 1 and 0, 6. So if R is the radius, let's say R is the radius, you can drop a perpendicular here. And this is the midpoint M. because if you drop a perpendicular from center, it will be meeting at the midpoint. So this is 0, 7/2. So for the largest circle, basically this R will be same as 7/2 only. From the diagram only you can make out. So clearly the radius will match with the distance from origin to M. So no need of solving it, 7/2 directly. So there is no need of mentioning the word largest actually. From here you can clearly make out the radius is same as this distance. The circle passes through 1, 0, 5, 0 and touches y-axis at 0, 0 h. If angle ACB is maximum, what is h? So it is touching y-axis at some C and it is passing through 1, 0 and 5, 0 on x-axis. And they're saying this angle has to be maximum, angle ACB. So if I name it as theta, theta should be maximum. What is h for that? Where this is 0, h. So if I just show something like this, that is this angle has some theta 1, this angle has theta 2. How are the three angles related? Exterior angle is equal to sum of interior opposite angles. So theta 2 is theta 1 plus theta. So theta is theta 2 minus theta 1. So therefore, if you want theta to be maximum, you can take tan theta and proceed. So tan theta, if I write, tan theta equal tan of theta 2 minus theta 1. And what is tan of theta 2 minus theta 1? Tan theta 2 minus tan theta 1. Tan of A minus B formula I'm writing. By 1 plus tan theta 2 into tan theta 1. And what will be the slopes? Tan theta 1 is basically the slope of this line. So the slope of that line is tan theta 1, which is h minus 0 by 0 minus 1. So that is minus h. And the slope of this line is tan theta 2. And what is the slope? Difference in y coordinates, h minus 0 by difference in x coordinates, 0 minus 5. So minus h by 5. So just put these values in that result. One of them is minus h. Which one should I write first? Theta 2, tan theta 2, that is minus h by 5. Minus tan theta 1. What is tan theta 1? Again minus h. By 1 plus minus h by 5 into minus h. So this is same as minus h by 5 plus h. So 4h by 5 by 1 plus h square by 5. So this is 4h by h square plus 5. So we want this tan theta to be maximum. So if theta is maximum, tan theta is maximum. So how do you get that? So you can also write this as 4 divided by h plus 5 by h. So for tan theta maximum, denominator must be minimum. Denominator must be minimum. And when will this be minimum? So usually you have reciprocal, so you can use AM greater than or equal to GM. So h and 5 by h, what does the arithmetic mean? The sum by 2 greater than or equal to geometric mean is root of the product. So h plus 5 by h is greater than or equal to 2 root 5. So this is the minimum value. And when will the minimum value usually occur? When the quantities are equal. Whenever you are writing arithmetic mean greater than or equal to geometric mean, when the quantities are distinct, greater than symbol will hold. And when the quantities are equal, equal to symbol will hold. So if when are you getting the minimum? When you are taking equal to. And when will equal to happen? When h equal to 5 by h. So for minima, what are the criteria? H equal to 5 by h. So h square equal to 5. And since the point is above the origin, you can't take negative. So h equal to root 5. So A is the answer. Anyway, there is no negative sign. Actually, it may touch down also. But they have not specified anything. So fine, you can mark h equal to root 5.